Hello and welcome back. This is part one of the last chapter in chapter 10 of 10.4. And we're going to be talking about areas with polar coordinates, polar equations. Now, if you remember, if you wanted the arc length, not arc length, the area, sector area of a circle, your formula was 1/2 r squared, and then the angle, theta. We're now breaking this up into tiny little d thetas, as small as we can make them, at delta theta, which turns into a d theta, as we're looking at this. And so r, in this case, is going to be our polar equation where it is a function of theta, meaning it depends on theta. And we'll start with our first one here. This is r equals cosine of 2 theta. And we want to find the area enclosed by one loop. Now, one loop is going to look like this for us. And so that's the area of interest. Now, I'm hoping, and by the way, we should be viewing, instead of like x, y, we should be viewing this as theta and then how far in the away from the origin we're going as we do this. So r in this case is here. So the area, based on the formula here, is going to be, the area is 1/2. I'm going to pull that 1/2 out since it's a constant. A to B are going to be my thetas. Now, how do I know that that's my theta there? Well, I can go off to the side. And can you see r is 0 here and r is 0 here? So when r cosine 2 theta equals 0, that means 2 theta is going to be negative pi over 2 and pi over 2. Which means theta is going to be negative pi over 4, pi over 4. And that's where these values come from. Now, in later cases, what we'll be doing is we'll have two functions, polar functions, and we'll have to set them equal to each other, but we're not going to do that quite yet. So negative pi over 4, pi over 4. Then we have r squared, which is the cosine of 2 theta squared, and then our d theta. And there we are. Now I'm going to notice that this is definitely an even function, cosine, and we can see that this top area here is the same as the bottom area there. So what I'm going to do is I'm going to change this, and I'm going to double the area times 2 and integrate only from 0 to pi over 4. And again, I'm basically finding the area of the blue here and then doubling that to fill in the rest of the loop there. Now my cosine squared becomes 1/2 1 plus cosine of double that, that's 4 theta d theta. And these reduce out, and I'm still left with a 1/2 there. And I'm going to end up with, when I integrate this, I'm going to end up with a theta from 0 to pi over 4 plus 1/4 sine of 4 theta from 0 to pi over 4. So let's see what we end up with. This becomes pi over 4 minus 0, so that's 1/2 times pi over 4 plus, now when I plug that in, that's going to be 4 times pi over 4. That's just going to be sine of pi, which is 0. And when I plug in 0, sine of 0 is 0. So this whole piece right here goes to 0. Leaving me with, that's a 2. So pi over 8 is the exact area of one loop in this, this is called a rose. Looks kind of like a flower. Doesn't look like a rose though. But so it's not too bad. Now for example 2, we're going to find the area of the shaded region. Now the shaded region didn't come out so well with this. So our shaded region of interest in this case is going to be here. And I'm hoping that you can see that we are going from theta equals 0 up to theta equals pi over 2. And those are going to be my boundaries for the function r squared equals sine of 2 theta. And what we're going to do is mess with our r a little bit. Now, I'm hoping that you can see that r squared we already have. So the area is going to be 1/2 from 0 to pi over 2 of r squared, right? That's our original formula. And we have r squared. R squared is just sine of 2 theta. So in this case, I could do square root and square it, but I already have r squared, so there's really no need for that. So that is going to give us don't forget d theta. I'm going to integrate that. That's going to give me a negative 1/2 times 1/2. So I'm taking this 1/2 here, and from the substitution, I'm going to get another 1/2 there. It's negative because the integral of sine is negative cosine 2 theta. And we're going to go from 0 to pi over 2. So here we have negative 1/4, just multiplying those together. And then this is going to become the 2 and the 1/2 here. It's just going to be cosine of pi minus cosine of 0. And this is going to give us negative 1/4. Be really careful with these negatives here. It'd be really easy to miss one. Cosine of pi is negative 1 minus cosine of 0, which is 1. And this becomes negative 1/4 times negative 2, which is just a positive 1/2. All right. Now for a third example, again, the shaded region didn't come out so clear. It actually, we're going to find the area of all of this shaded region here. So half of that there. And here's our function, r equals 4 plus 3 sine theta. And to do that, what we need to do is recognize that our boundaries here are from negative pi over 2 to pi over 2. So it's facing downward, and then we're going all the way to positive pi over 2. Those are our boundaries. In our area, once again, it's going to be 1/2 the integral from negative pi over 2 to pi over 2. And our function here is going to be squared. D theta. So this is going to get a little messy. We can't use symmetry here because the area down here is not the same as the area up there, unfortunately. You end up there. And that's going to get a little messy. Let's clean that up a little. And we are going to end up having to rewrite using this rule here. So that means we have 16 plus 24 sine theta plus 9 halves, that's from there, 1 minus the cosine 2 theta, and all of that d theta. So we're going to end up with 1/2, and we're going to get 16 theta minus 24. Remember, the integral of sine is negative cosine, plus 9/2 of theta minus 1/2 sine theta, 2 theta. Now, what's very nice about that is because it's odd, this whole part goes to 0, which is nice. And for this theta here and this theta here, what we're going to get is pi over 2 minus pi over 2. So that's actually just pi over 2 plus pi over 2. It's going to give us 1/2. 16 times pi, because pi over 2 minus pi over 2 is just pi, minus 24. Cosine of pi over 2 is 0. Cosine of negative pi over 2 is also 0. Plus 9/2, and once again, we have that theta, so that's just going to be pi over 2 minus pi over 2, which is just pi. And overall, distributing the 1/2 and combining my like terms and everything, we're going to end up with 41 over 4 pi. So I'm hoping that you can see the calculus part of this actually is pretty easy. It's really not so difficult to do. It's all the algebra and the trigonometry and everything that you have to remember that can really be a little trying. All right, let's move on to page 2. There we are. So this one's a little more aggressive. So we're going to find the area inside of one of them and outside of the other. Now, a couple of things that we're going to need to do here. First of all, we're going to need to acknowledge what area we're even talking about. So this one here, this graph here, is this one here, 1 plus. And this circle, this big circle with radius 3, is this one here. And so the area of interest is actually going to be this area here, all this area between one and the other. So we're going to actually end up having to do some subtraction. And what's going to happen is we need to find where they intersect. So let's take a second and acknowledge that, meaning where the two equal one another. Theta, and you can see I can subtract that to the other side. Which means sine of theta equals 1/2. And where's that going to be? Well, sine is positive in both quadrants 1 and 2. So this means that theta is pi over 6 and 5 pi over 6. And those are going to be our boundaries. So what I'm going to do is I'm going to find the area of the one is going to be the same as the area of the other, meaning it's symmetric here as it is there. So we are going to proceed with that. Now, I'm going to get a little low on room here. So I'm going to bring this up here. And the overall area is going to be 1/2 the integral. And what I'm going to do is I'm only going to find this here. So I'm going to go from pi over 6 to pi over 2 and then double it. So pi over 6 to pi over 2 and double it. And it's going to be this area squared minus this area squared. This is the second one there. Squared. So as you can see, this is going to get a little messy. So I'm going to go ahead. And again, I'm doubling it because I'm only going from pi over 6 to pi over 2. And then we can see it's the same area on. So those are gone. This is 9 sine squared theta minus, and squaring that is going to give me 1, and they're all going to be minuses, minus 2 sine theta minus sine squared theta, all d theta. All right, so I'm going to go ahead and combine up these like terms. So that's going to give me 8 sine squared theta minus 2 sine theta minus 1 d theta. Now we can actually integrate. This one, I'm going to have to use that rule again. That one there. Now, that 8 there is going to reduce with that 2 there. So this is going to give me 4, the integral from pi over 6 to pi over 2 of 1 minus cosine of 2 theta d theta minus 2 cosine theta from pi over 6 to pi over 2 minus theta from pi over 6 to pi over 2. So we have a lot going on here. So integrating that is going to give me 4 theta from 6 to pi over 2 minus, I'm going to get an extra 1/2 from that. So that's going to be a 2 sine of 2 theta. Oh, and I need to acknowledge when I integrated that sine, that should become plus there. Integral of sine is negative cosine. All right, so we are to here from pi over 6 to pi over 2 plus 2 times cosine of pi over 2 is 0 minus cosine of pi over 6 is root 3 over 2 minus, and here we're going to end up with pi over 2 minus pi over 6. Okay, so now we have 4 pi over 2 minus pi over 6 minus 2 times sine. Now when I plug that in there, the 2's will reduce, so that's sine of pi, that's 0. When I plug that in there, the 2 and the 6 will reduce to pi over 3, so that's going to be root 3 over 2 minus root 3 minus, and let's do that arithmetic over here real quick. So that's going to be 3 pi over 6 minus pi over 6. It's going to be 2 pi over 6, which is pi over 3. That means that also will be pi over 3. So this is 4. We just established that that's pi over 3. 4 times pi over 3. That becomes plus root 3 minus root 3 minus pi over 3. And these go away. That becomes 4 pi over 3 minus pi over 3. That becomes 3 pi over 3, which is just pi. And here's what we mean by this. The green area in total is exactly pi. That's somewhat astonishing. That's quite amazing that we could do that. Let me just show you the work again real quick, in case you can get the whole thing in one frame, barely. There it is. So hopefully you can break that down. It's not too bad. Let's move on to our last problem for this video. This is, again, part 1. Find the area of the region that is inside R3 cosine theta and outside of R equals 1 plus cosine theta. All right. So let's draw a picture to get a better idea of what it is that we are doing. And by the way, I'm hoping that you can see the parallels here and here. I'm going to guess that the area is exactly going to be pi again. But let's see what happens. All right. This is exactly this picture here, except it's exactly sideways. Well, that's now y and that's now x. And what I need to do is find the points of intersection. Those are going to be slightly different. So let's set the two equal to one another. So 3 cosine theta equals 1 plus cosine theta. 2 cosine theta equals 1, which means cosine theta equals 1/2. Now, cosine theta is different than sine theta, equaling 1/2. So what are we going to get here? We are going to get the boundaries. Theta equals pi over 3, negative pi over 3, and pi over 3. And once again, if we acknowledge that this is the graph, but it's sideways like this, I'm only going to integrate from 0 to pi over 3 and then double that, because that area is going to be the same as that area. So here's what our area is going to look like, or our integral. It's going to be 2 times 1/2, 2 because, again, I'm using the idea that I'm going from 0 to pi over 3 and just doubling that to get that there. Integral from 0 to pi over 3 of inside this one, so that's 9 cosine squared theta minus 1 plus cosine theta squared. And that actually is going to give us and combine. I'm hoping you can see the parallels. I mean, this is almost the exact same integral that we just did. And of course, I will need to use cosine on this one here. All right, again, I'm going to break it up into 3 separate integrals. Now, when I use this here, that 1/2, that just becomes a 4. That becomes -2, and the integral of cosine is just sine, pardon me. From 0 to pi over 3 minus theta from 0 to pi over 3. So this becomes 4 theta from 0 to pi over 3. Now I'm going to get an extra 1/2 out of that integral. So that just becomes +2 sine of 2 theta from 0 to pi over 3. Minus 2. Now, sine of 0 is 0, but sine of pi over 3 is √3 over 2. Minus pi over 3. Right, pi over 3 minus 0 is just pi over 3. All right, this is going to become 4 times pi over 3 plus 2 times. Now, this becomes sine of 2 pi over 3. Now, 2 pi over 3 is in quadrant 1, which makes it positive, √3 over 2. Minus 0, right? Minus √3 minus pi over 3. And you can see that just becomes pi over, √3 minus √3. So this whole part here goes to 0. And 4 pi over 3 minus pi over 3 is 3 pi over 3, which is just pi again, as we predicted. Not too bad. Part 2 is coming up.